All right, we're going to go ahead and get started now. Thank you for joining us today at our webinar. This is API security needs grow ever larger. And, APIs are the most rapidly growing attack surface, but they still aren't widely understood and can be overlooked by developers and AppSec managers. So in this webinar today, we'll discuss cautions, we'll discuss best practices and approaches to ensuring the security and discovery of your organization's APIs. So before we dive in, just wanted to do a quick introduction. We have myself, Andrew Garrett. I work in product marketing here at Micro Focus Fortify, and I am pleased to be joined today by Shawn Simpson, who is the product manager for Fortify DAST, which includes Web Inspect and Scan Central DAST. So we're planning on taking about 45 minutes for our presentation today, and then we will leave a little bit of time at the end for a live Q&A session. So we hope you'll stick around for that. If you do have any questions, feel free to chat those in using the chat function, and I'll be monitoring those as we go. And just as a reminder, this session is being recorded currently. And so if you would like to review the presentation afterwards, you will receive an email of the recording as well as the slide deck for your review. So you'll be able to rewatch it and check out the slides again after we're done here today. So with that, Shawn, I'm going to pass the mic over to you and looking forward to getting started.
Thank you, Andrew. And I'm actually going to turn off my video so I don't have to stare at myself while I talk. So API security is, as Andrew said, it's one of the fastest growing attack vectors that we're seeing in application security as a whole. And while there's really, I always say there's nothing really special about API security. In a way, it's just you have to consider it within context. So we have the same sort of vulnerabilities that APIs are susceptible to: SQL injection, command injection, cross-site scripting. We need to take care of the same sort of use cases: authentication. Make sure if endpoints within your API require auth, we are scanning with auth. We're not getting 500s and 404s, which actually with APIs can be a little bit easier to determine during a scan, which is nice. And then, there are some emerging technologies within APIs that have really, made security experts nervous. Things like GraphQL, which has combined some unique risks when thinking about API security. Next slide, Andrew. So while we're going to really talk a lot about how to really secure APIs, specifically what we need to do, I also want to first, though, take a step back and talk about what we need to do with any good security policy when considering securing a web app. This starts with design reviews. This starts with threat models, understanding where do your applications, whether API or traditional, have inputs, can reflect things back to users, where logs go, where things are stored, third-party pieces, all of those things. They all start with a design review, making sure we understand the landscape that we're even trying to secure. Next, I think we'd all like to write perfect code. That's not a reality. So security scanning, some sort of tool set to do that. DAST is a great one, it has outside-in viewpoints. Static is another great one. It's comprehensive, it gives you the breadth. But then, concluding with your high risk, high value applications with a true penetration test is important as well. I always like to say, though, when considering a penetration test, go ahead and do a lot of the low-hanging fruit with your DAST and SaaS tools, pass those on to your penetration testers, make their job a little bit easier so they can focus on really hard problems, the things that an automation tool can't do. But these are just kind of some of the high-level things we need to think about, regardless of what we're trying to secure, API, traditional app. It's about, a layered defense. Next slide. So Fortify, we've really tried to look at the breadth of what's involved in securing an API. And, at the core, we've got some sort of application which we've exposed an API and it's giving us input and output from that. This leads into what we call kind of the 4 A's. We have our attack surface, and we'll dive a little bit more into each one of these and why they're important, what you need to consider. But we have the attack surface. That's what we're actually trying to secure. How do we authenticate it? When we're doing that scanning, we make sure we maintain state. What are our actual attack vectors into the application? What are the parameters, the endpoint, the specific vulnerabilities we're trying to test for? And then, of course, the days of having many dedicated professionals, being able to spend a lot of time on an individual application are, that's part of the past at this point. So we really need to consider automation scenarios as well, because continuous testing is a critical part of any sort of security. New 0 days come out. We want to use continuous testing tools that are kept up to date to make sure we know the current posture of our applications, not the historic posture. Okay, next slide. So we'll start with the attack surface. This is about thinking of how do we expose this API to some sort of testing tool. And this actually can be the same thing, for a pen tester as well. We can start with things like schemas. A schema is a best effort by somebody to essentially document the API. There's tools out there that do things like schema validation. This is a pretty useful tool when doing security testing. But we can also use these schemas to drive security testing tools as well. So some of the traditional ones we can think of with WSDLs, with SOAP. OpenAPI, though, has really raised the bar on schemas with their OpenAPI definition. Many people think of that as Swagger. OpenAPI 3, they renamed it. But it gives us a standardized way of developers being able to document their API, both for allowing other people to learn how to use it, but using it from a security context. The second thing we want to think of when scanning an API is how do we exercise that within any sort of testing tool? A classic way of doing that is something we call a workflow macro. Those are sort of outside-in tools that can generate repeatable HTTP traffic. So Postman, Burp, we have something called our Service Test Designer that's used for SOAP testing. SOAP UI is one of them, Selenium scripts. These are all tools that you can capture a workflow of how to interact with an application and repeat it over and over again. And these are a critical piece for exposing that attack surface when thinking about scanning an application, making sure we have good coverage of it, making sure we get that outside-in viewpoint of it. But also being that repeatable is really key. If we have something that is non-deterministic, then we're just kind of hoping. So we need something that every time we scan it, we're going to get the same result. And for the Fortify products, we've actually standardized on Postman as being our primary way of exposing these sort of automation tools, being able to repeat the API scans. Postman's a great tool for API testing. It gives you kind of the breadth of REST, SOAP, GraphQL, RAML, and they keep it very up to date. Next slide. Yeah, so the next piece of that attack surface, though, is the ones I just talked about are when we really understand the API already and we know what's there, it's nice. We have schemas, we may have artifacts from other tools that we can use to reproduce that traffic for security scanning. Many cases, though, security teams, QA groups, whoever it may be, they may not know. Pretty much every application at some level is using APIs. It may not be HTTP, but there's an API being used. So we may not have a well-defined doc on what's there, what we need to test. So we need some way to automate API discovery. This is something we've put a lot of effort into Fortify, and we're seeing it as a big industry trend, is understanding that the API exposure across an organization. And this comes in a couple different flavors. One is the larger enterprise. Where do we have web apps? Where do we have APIs? And what is in them? But this is also within a traditional web app. So one of the things we've tried to do, and we're already doing this with Swagger, is anytime we come across a Swagger definition within an app, a lot of times these are on because some framework is being used and is on by default, or the documentation section has a link to a Swagger definition. The security tester may not even know it's there, but as Web Inspect or any of the Fortify tools are scanning that application, we may come across that Swagger definition. We want to bring all of those endpoints that we find in that API and treat them like a traditional web app, because they're really just another attack vector within that larger API or larger web application. So that API, think of it less as something that is a unique thing to scan and make it just part of that outside in view of an application, test everything all at once. And so being able to do things like that. Another aspect of that is things like verb discovery. A traditional Swagger definition is only going to show what the developer thought was relevant. But many times there are hidden endpoints that only they can use, only they may use for connecting their client to their server, but they only want to expose some of those endpoints on the server, so they don't put all of them in the Swagger definition. A lot of times those can actually be figured out by things like verb discovery, where you notice an endpoint has a put or a get on it. Well, let's test a post on it. More importantly, too, maybe this endpoint has a delete on it. That may be unintended. So we want to make sure we expose all of those during that security testing, because while some of them may not expose a traditional AppSec thing like cross-site scripting, understanding what an attacker may be able to do. If there's a delete you can run through an API directly on a database, that's just as large of a security concern as a SQL injection. Other things to consider when we're trying to understand that API landscape. Next slide, please. Then we have authentication. So we've discovered our API sitting in our application. We know all the endpoints. That's great. But to do any sort of automated testing, we now need to maintain state against that API, just like we would log into a traditional web app. There are some standards around that, JWT tokens, OAuth 1 and 2, all of those sort of things. Many times though, developers write custom ones. There may be a standardized one within an organization. So automated tools need to support all of those as well. Bearer tokens has become one of the big standards being used, as well as JWT and OAuth 2. So those are really important things to consider. Postman as well. Postman has the ability to generate authentication workflows. Those authentication workflows can be run actually as separate workflow macros within a Web Inspect scan, for instance, to maintain that state while the primary Postman collection is exposing all of those endpoints, allowing us to test, make sure we know everything. We lose state for something, security testing is quite often going to do malicious things. The server is going to see some of those and invalidate those session tokens. You always need a way to reestablish that state in an automated way. So that's where those secondary authentication workflows come in. Next slide, please. The next way of doing this, though, is as we're trying to now think of, that's a great solution for one-off APIs, but how do we do things like this at scale? How do we do this when we don't know there really is an API there? And this is something we took a look at Fortify and with Web Inspect, and we're thinking, okay, if we're going to do API discovery, if we're going to bring on all of these endpoints, do verb discovery, all of these things we're going to do to try to automate APIs, what's the point if all we're going to do is tell the user, okay, yeah, you've got an API there, but I can't scan it because I can't authenticate. So we're looking at being able to do this state detection and gathering state in an automated way. Turns out, many times within an API, there is some endpoint we already have that is establishing that state. So just by watching traffic and using, and this is going to be using some of the standard like OAuth 2, JWT, bearer tokens, is when this will work. But we can watch that traffic go by and see which endpoints are called, what was the context they were called in. As they make that request, gather that token, and then establish state for the next request. Also, what triggers loss of state? How do we detect that, this request here was generating 200s. We're getting good coverage. We're sending attacks, and we're seeing good responses. I send this request and I get a 500. I've lost my state. So being able to both detect how to establish state and how to maintain state and how to reestablish state is a critical piece, and that's what we call our automatic state detection. It does work with OAuth 2, JWT, and bearer tokens. So we'll watch all that traffic as it's passing by inside of Web Inspect and Scan Central and automatically establish that state any place we can, so that, again, when we discover that attack surface in an automated way, now we can authenticate in an automated way, which is really key to being able to scan those hundreds, if not thousands, of applications that teams need to scan these days. Next slide, please. Then we have our attack vectors. So these are really both the parameters and endpoints that are susceptible to attack, as well as the individual attacks that may be applied to them. So when we think about a traditional web app, there's the big ones: SQL injection, cross-site scripting, the various command injections. Some of the big ones we've heard recently, JNDI injection, which led to Log4Shell. These are all relevant in greater and lesser degrees within APIs as well. Then we have things like GraphQL. GraphQL has really shaken up, I would say, recently the security industry when it comes to thinking about APIs. GraphQL has, there's a couple things specific to it that, and to a lesser degree, happen in other API frameworks, but in GraphQL, you have the concept of you can't do things like rate limiting and batching, for instance. And we need to take those into account when we're thinking about these attack vectors. A denial of service against a critical API is a big deal. So the example I'm using here with GraphQL of batching. GraphQL allows you to combine numerous queries against the API into a single request. And there is, there's no, by default, single limiter to that. If I want to send 1,000 queries in a single, GET request, I can do that, which obviously, can lead to things like a denial of service attack, which, as I said, for a critical app, that's as big of a deal, as you'd find, with the SQL injection, something like that. The IRS, on April 15th, someone can just hit their API and, overload their servers. That's a big deal. So that's the sort of thing we need to look at with GraphQL. There's some things you can do with it as well, where you can combine cross-site scripting and SQL injection into a single layered attack by using some of these sort of batching techniques, where You can do the traditional things of embedding requests into something you send to someone with an email, but because of that batching ability, that can spawn a cross-site scripting attack that then leads to an immediate SQL injection attack in an automated way. So the attack vectors of APIs, while they have a lot of the traditional risks, they're in a new context and they're combined in new ways that our research group is taking a look at, taking very seriously. But we also know the bad actors out there are looking at these as well. So we have a targeted API policy within WebInspect and our DAST tools that takes these things into account. It looks at all of those sort of things like SQL injection, cross-site scripting, command injection. We also have a number of checks very specific to those authentication mechanisms I was talking about before. OAuth2, JWT, there are things you can do with those around, time of tokens, things like that, session fixation. So it's important to make sure when we're looking at security tools that they're not just throwing the traditional web app requests against the API, but they really are looking at them within the context of an API for the unique vectors that exist there. Next slide, please. I think we looked at this one already, didn't we? Yeah, we did. But this is actually kind of reinforcing what I was just saying. That rate limiting and denial of service is exactly what I was talking about with GraphQL and how really risky it is when a developer takes the most interesting. GraphQL is a pretty exciting technology to be working with, and it's a very powerful technology. Being able to embed a query language within your application, it's a very compelling use case to allow sort of that those sort of queries that that the user may come up with that the developer hasn't even thought of. So there's a lot of value in it, but we do have to consider that GraphQL, attack vector very, very seriously. Next one. So all of these other things I've been talking about so far, these are important when thinking about a standalone API. There's no doubt about that. But as I think I already mentioned, the days of being able to fully focus on a single application, yeah, a dev team can do that, a QA team can do that, but a small internal security team are typically looking at a portfolio. To be able to successfully scan and monitor continuously, a portfolio requires automation. So here at Fortify, when we've been thinking about that, those first 3 A's are all about how do we get to this automation scenario where we can make sure this is done at scale. We have to be able to discover, we have to be able to authenticate, and we have to have the comprehensive breadth of checks to be able to do that. So everywhere we've have WebInspect, have our DAST tools, we've taken API security and we've actually made it a specific piece of it that can be automated on its own. This graphic here is actually from Scan Central DAST, which is our automation platform. It allows that centralized management, which is key. It also gives you the ability to look at trends. Traditional tooling is about getting a snapshot. What we typically need, though, when we're looking at portfolio is more than we're looking at the current state of where are all of our scans, where are all of our applications. More importantly is the trending. If I'm looking at an application early in the life cycle, it's early in development, we may have done our design reviews, we understand what the application is going to be used for, but the actual development is in progress. Yeah, it's okay for that, those security vulnerabilities to be trending up, as long as they're not trending up too high. You want to make sure your team has time to mitigate them. You want to watch those graphs as, the work is being done, but you want to make sure it's being taken seriously. A more mature application, something that may be in production, any sort of change, any sort of a major thing may be indicative of a 0-day. It may be a new check that came down with a recent update to your tooling, and has exposed, a 0-day, something like that. We want to make sure we can mitigate those and react. So when we think about APIs, we have to take a look at it in that sort of holistic approach of how it fits in with everything, and understanding the life cycle of an application is key to doing that, making sure we're making the right decisions at the right time of it. And we need something like an automation platform like the Scan Central DAST, and Software Security Center, FOD, to do those sort of trending, make sure we understand where things fit. Next slide, please. Yeah. So this right here is kind of my big pitch for Scan Central DAST, how we think about it. It is our automation platform here at Fortify, and it is meant to sort of seamlessly fit in with whatever team is working with it. I mentioned quite often the traditional security team. They're working with that very large portfolio, but for them to be successful in their job, they need to, what we call, shift left, allow developers, allow the DevOps teams to really take their applications as early as possible in the life cycle and start doing scanning of it. I think it's pretty much industry common knowledge at this point. The earlier we find a defect, a security defect, a quality defect, functional, whatever it may be, the earlier we find it in development, the cheaper it is to fix it. So allowing our developers at design and coding time to be able to test and get that feedback quickly, allow when our DevOps teams takes those, get them into the build process, allow the tooling to fit in with their workflows as well, is critical. The QA teams as well, and the QA teams quite often are building these artifacts that we can use to run these tests. Functional tests, Selenium scripts, things like that. These are quite often, our QA teams are the application expert within an organization. Developers know what it's supposed to do. QA actually knows what it's really doing and can create artifacts that we can then use for this security testing. And that's something we've worked really hard to fit Scan Central DAST and FOD so that it can be integrated in with each point of this in a containerized and simplified way. Next slide, please. We're getting close to question time here. Yeah. So with that, there's a lot going on with API security. Definitely GraphQL is one of the most exciting and interesting things, but just really understanding API postures, policies within an organization. One of the biggest things I hear from customers is we don't even know where the APIs are. So it's one of the key things we're trying to do here at Fortify is to reduce that burden. With that, I'd love to open it up for questions. And I think, Andrew, do you have any in chat as well?
I do, yeah. We've had a lot of good questions come in through chat. So thank you all for your participation today. We've had a good group, and just as a reminder, we've had a couple of questions come in about requesting the recording of this presentation, and we are currently recording, so we will have a recording available to share with each of you today. So with that, let's kick off our Q&A portion of the webinar. First of all, Shawn, you were just talking about Scan Central DAST, and so I'd like to start off with a question about Scan Central DAST specifically, and its API scanning capabilities.
Yep.
So, how does Scan Central DAST compare against niche API security players, and what are some of the differentiators?
When I've looked at a lot of the companies out there who are doing API security right now, and what we're finding is a lot of API security organizations right now are really looking at the schema. The and doing some sort of schema validation, because it's really what you have access to. And as I kind of put a lot of thought into what is the best way to secure an API versus, a traditional web app, over a lot of thought about that, my conclusion is an API isn't particularly special. All of the same techniques we use for traditional web app actually apply to APIs. So it's about making sure we can onboard that application as easy as possible, do the authentication, and understand the breadth of it. Schema validation is a useful thing. But what it's really doing is telling us, did we document properly? Now, there are some tricks to it as well. There's some flags and schemas you can do. This one's not specific to APIs, but just doing things like having HTTP only, as a header flag. Those sort of validation things, they're useful, but they're not going to ever find something like a cross-site scripting or SQL injection. You really need some sort of either static analysis tool or dynamic analysis tool. You need to take that inside out or outside in look to really do them. So that's where we've taken ScanCentral DAST, and we've tried to really apply the techniques that have been successful for, at this point, decades to APIs, which is being looked at in an emerging way, and being able to integrate in with Postman, as I said, to use all of those artifacts we already have, as well as use our discovery abilities to find the APIs you don't even know about.
Yeah, that's great. And a follow-up question, again about ScanCentral DAST, but likewise, when compared to attack surface management tools, how does ScanCentral DAST compare? How should Web Inspect, ScanCentral DAST, for example, be positioned against ASM technologies?
Well, yeah, attack surface management, I usually think of that as a portfolio view. And, ScanCentral DAST is a component that fits within Fortify Software Security Center, which is a great platform for looking at that entire portfolio. It's doing it in a different way. It's doing it in a directed way as opposed to maybe automated way, but it accomplishes at the end of the day, I think, the same set of needs. You can take a look at your portfolio. You can get a snapshot of exactly where are my risks right now. But more importantly, as I mentioned, you can see trends. You can see emerging risks come up, and you can get that dashboard view of it to really take a look at it. And that's one of the nice things about ScanCentral DAST to me, and one of its key value pieces is that it does bring DAST scanning and the automation, the orchestration. It gives you that single dashboard to understand what all of your tools and sensors are doing, but it also integrates in with our Software Security Center, where you can get that big, wide portfolio view of everything.
Yeah, that's great. And we've had a couple other good questions come in here, Shawn. We have someone asking, how do you cause a GraphQL denial of service if you don't have a cyclic relationship in your schemas?
Well, I mean, GraphQL allows batching inherently. You don't actually need the cyclic relations. You just have to have batching not disabled within GraphQL, or potentially you could do something like you need rate limiting is another key one within GraphQL. By default, there is no rate limiting to requests, which inherently makes it susceptible to denial of service. But
okay. And then another question here about APIs and REST APIs. It says, how will you secure? So I think just asking kind of what are some of the best practices for securing APIs, REST APIs?
I mean, first, when dealing with the REST API or any API, is understanding the risks of it. Start with the design review, which is critical. Understanding what sort of data can get into it, how any data can be manipulated by it, what endpoints, can interact through either directly or through business logic, to the database, things like that. That's going to be key. Understanding the API and the threat posture of that API, you have to start with that. Then it's very similar. It's similar to any other web application after that, making sure you understand good coding practices. So, cross-site scripting is all about sanitizing your endpoint, your inputs. Same with SQL injection, making sure that you either are completely sanitizing all of the inputs that may be coming from the outside, making sure only the types of requests your code is expecting can make it to, a critical part of that code. So the tick 1 equals or type stuff like that you see in SQL injection, we can do things like use stored procedures. Stored procedures get a bad rap. They're painful to deal with as a developer, but if you have a procedure within your SQL database that only allows certain endpoints, it does give you a layer of protection. So that's a very broad question that I can't really answer, comprehensively, but those are the sort of things you need to do, is understand what are your risks. And yeah, if I had to do one thing, it'd be sanitize all the data I have coming in, make sure no one can slip something through that shouldn't, be coming in.
Yeah, and that's definitely a question that, like you said, requires. We could do a whole webinar. Spend an hour just on that. But those are some good points. So here's a good question, Shawn. And I know you are the DAST expert, but this question is pertaining to SAST. But what is CyberRes support for API security in SAST?
So we do also have it in SAST, but it's it's looking at it from that inside out point of view. And a lot of these sort of risks we have with an API security, it applies the same way with DAST and SAST. SQL injection and cross-site scripting, it doesn't matter what the endpoint is. What the front end of an application is doesn't really matter to that actual vulnerability. So our SaaS products are very comprehensive, as well with doing API security. They can find the same sort of vulnerabilities, whether it be a traditional web app or an API. And on top of that, they have specialized checks as well. Same sort of things we have where we look at things like GraphQL. I was talking, I forget the name of it. Our research team had a number of checks coming out with, I want to say, it's one of the major GraphQL frameworks actually, in one of the upcoming releases. I can't remember the name of it off the top of my head. So, while there are framework specific things, we may add or take a look at, it's all about making sure you have the breadth of coverage within it. So, and yeah, it's an API at the end of the day, whether you have a web UI in front of it or, RESTful endpoints, it's the code behind it where the vulnerabilities quite often live. And our SaaS products do a great job of detecting those.
Yeah, and we've talked in the past, Shawn, about the benefits of SAST and DAST testing, and how combining those really gives you that more holistic view. You get the inside out, the outside in. So really, organizations need to be vigilant in deploying both testing methodologies.
Yeah, I always say SAST gives you breadth, gives you completeness, but a lot of those things, may not actually apply within your scenario, but they do give you a good understanding of everything that could happen. DAST tells you exactly what is happening. It's coming from the outside in, just like, and it attacker really will. And most actual attacks from DAST are true exploits. When we do a SQL injection attack, we're quite often really getting data out of the database. It's not a possible, it is a confirmed. Here is your data. We got it through this SQL injection attack. So to me, they're, they are two products that work very well together and give you a much more comprehensive coverage by working together.
Yeah, and speaking of working together, another question that just came in here, is there any correlation done between the SAST and DAST results to get better insights?
So there is. We actually had a feature come out last year. If we're using Scan Central DAST with SSC, we're starting to share that data when we have all of those on-premise products working together. Initially, what it's doing is taking those static results, and then when we queue up a dynamic scan, we take those results and we craft targeted attacks from them against the application. So we're doing that outside in, like really exploiting what we thought was a possible with SAST. And if we find it, we consider that correlated, and we show that within SSD that this was a finding. We found it statically, we confirmed it dynamically, and here is your results. And we think that really helps with understanding priority as well, because that can sometimes be a problem with static, because it does give you, it is so comprehensive. It can be sometimes difficult to prioritize, but if you confirm it dynamically, there's no doubt about it.
Yeah, and Shawn, a question about burp. Is burp SAST or DAST?
Burp, it would be considered DAST. I mean, it's a traditional man-in-the-middle proxy, really, is where they started out with. And, burp is a really useful tool. We actually, WebInspect has plugins that work with burp. Burp has, we've had a long-standing integration with them that works really well, and they have a great tool. But yeah, it is. It's not a traditional DAST tool, I would say. It is more of a security man-in-the-middle proxy that can be used more as a manual testing. I know they're adding some automation to it over the last few years with their enterprise, but I wouldn't really even call it fitting quite in the DAST realm, but it's closest to that.
Yeah, and we're getting a little short on time here, but I think we have time for a couple more questions.
Okay.
But this question here is about WebInspect specifically. Where does WebInspect notify you if it detects an API? Is it in the profiler?
No, it's actually during the scan. We have, it will show up as an informational finding now, and you'll actually be able to see those endpoints in the site tree. So a check will actually flag within WebInspect when our discovery triggers and it's found like a Swagger definition or something. And so you'll see that informational. We found this Swagger file at this location, but also within the site tree, those endpoints will then show up. Excuse me.
Okay, perfect. Well, I think this is a good question for us to end on today. It's about shifting security testing left. But can DAST scans turn around results within the time frame expected by developers? Can you constrain the scope of your scan, for example, to just look at the APIs?
Absolutely. One of the features we have in Scan Central DAST, which I think is really all about doing this, is what we call our fast proxy. The idea of it is for taking functional tests, being run in a CI/CD pipeline, build pipeline, running really short targeted scans against them. And we have a number of customers who are doing this now. So as the QA tests are being run during that build pipeline, the result, the traffic generated by them is also being picked up by our little fast proxy that takes them, sends that capture to Scan Central DAST. Scan Central automatically queues up a scan. And because they're such small targeted ones, they're fast. I mean, I quite often, 1-2 minutes, 5 minutes. It depends on how much is being done with that functional test. But again, these are very targeted, very fast. And while this may not be something with a very dynamic team you want to do every check-in, this is certainly at the point of being, on the nightly build. So we're seeing a lot of adoption and a lot of excitement around that feature.
Well, that's great, Shawn. And I want to thank you for your time today and for, taking so much time to answer some of these questions coming in. We do still have some more questions that we're not going to be able to get to today. But I do want to say, if we didn't get to your question, we will make sure to reach out to you to make sure you get that question answered. Unfortunately, we don't have all the time that we would like, with Shawn. We would love to spend the whole day picking his brain, but we do have to let him get back to work today. So, but want to say thank you again, Shawn, for talking to us today about API security, and to our viewers today that have joined us. Want to say thank you for your participation, and again, stay tuned for the recording and the slide deck if you'd like to review this again at a later date. And Shawn, any final thoughts from you before we wrap up today?
The big thing is API security. Understanding your posture, understanding where your APIs are. It's absolutely the first step in making sure things are secure. And if you don't know an API is in an app, there's probably one in there somewhere. So it's good to get that understanding early. But thank you for moderating, Andrew, and thank you everyone for your time.
Yeah, absolutely. Thanks for joining us today, and we'll see you again at another webinar very soon. Have a great day.